For this example, we're going to try to determine whether the improper integral right here is convergent or divergent. If it's convergent, then we can evaluate the integral. So before we begin, we're going to have to rewrite and take the limit instead. So the limit as t goes to negative infinity, take the integral from t to 0, x over x squared plus 1 cubed dx. So you can see that we're going to have to use a u substitution. So for u substitution, I'm going to let u to be x squared plus 1. Therefore, du is going to turn into 2x dx. So because we only have x here, we're going to have to get rid of that 2, divide by 2. So I'm going to go back and go ahead and just do some preliminary work. I'm not going to write the limit because we're going to have to go back and use x anyway. So we have 1 half u cubed, so I'm going to put u negative 3 up here. So the integral is going to be negative 1/4 u to the negative second power. So I have the negative 2 divide, and then I have that 2, so that turned into a 4 right there. Okay, now I'm ready to write. I'm gonna go ahead and put x squared plus 1 back in. So I have limit as t goes to negative infinity, negative 1/4, x squared plus 1 to the negative second power. We try to evaluate from t to 0. So that's just taking the limit as t goes to negative infinity, and we have negative 1/4 x squared plus 1 squared from t to 0. So that's going to be the limit as t goes to negative infinity, negative 1/4 plus 1/4 t squared plus 1 squared. So you can see right here that as t goes to negative infinity, this one goes to 0. So we have negative 4. Negative 1/4 plus 0 is going to be negative 1/4. So this is conversion. For this problem, I'm going to let u to be cosine of theta. Therefore, du is going to be negative sine theta. So you can see right here we have the sine theta, so we're just missing the negative here, d theta. Okay? So I'm gonna just go ahead, go straight into, I'm not gonna go and write the u substitution. So you can see that we have the u substitution right there. So I'm just gonna go straight into taking the limit here. So limit as t goes to infinity from 0 to t, sine theta e cosine theta d theta is going to be the limit as t goes to infinity. I'm going to take care of that negative, so I'm going to put a negative there, e to the cos theta, cosine theta. And then we want to evaluate from 0 to t. So this is going to be limit as t goes to infinity, negative e cosine t plus e. So you can see that the limit does not exist. Since cosine is just going to oscillate in values between negative 1 and 1. So cosine of t oscillate in values between -1 and 1. So this one, we're just going to go back from e to the -1 and e +1. Therefore, the integral is divergent. For this problem, you can see that we have a discontinuity at 0 right here. So if I have 1 over 0, it's going to be undefined. Therefore, we're going to have to rewrite the integral into two different integrals. From -2 to 0, dx over x to the 4th, plus from 0 to 3, dx over x to the 4th. But if you want to integrate from -2 to 0, dx over x to the 4th, we're going to have to take the limit as t goes to 0 from the left, and that's going to turn into a negative x negative 3 power over 3. I just integrate and I go from -2 to t, which is the limit as t goes to 0 from the left, -1 3t cubed minus 1 over 24. But this is going to give me infinity, okay, as t goes to 0. Therefore, the integral is divergent. For this problem, if we look at w equal to 2, there is an infinite discontinuity. So we're going to have to rewrite from 0 to 2, w over w minus 2 dw is going to turn into the limit as t goes to 2 negative from 0 to t. One plus 2 over w minus 2 dw. To go from here to here, you simply do long division. So if I take w, I divide by w minus 2, I'm going to get 1. So that's going to be 1 times w, 1 times -2. Then when you subtract, that's a 0 here. So 0 minus -2 turns into a 2. That's why when I rewrite is 1 and then the remainder over the divisor. Okay? Let's keep going. So we're going to take the limit as t goes to 2 negative. That's going to be w plus 2 ln w minus 2 absolute values. Then we go from 0 to t. Let's try to evaluate. T goes to 2 negative, t plus 2 ln t minus 2 minus 2 ln 2. And this is going to give me negative infinity. Therefore, the integral is divergent.